Okay, who here likes competitive sports in any fashion? Okay, not enough of you to do something real, so we need a competitive sport that doesn't exist but should. Quidditch? Okay, I heard no other suggestions, so we'll do it. All right, so to have a competitive sport, you need at least what one thing to have competition? Teams. Multiple teams, and each team needs to have players. Cool. We're going to create a registry for Quidditch. So, function, register team. It's going to take in a team name. The team had what, did we say? Players. So let's create players on that team. Players ends in an S, so we instantly know it's an array. Perfect. Okay. We're practicing closures, so how do we start a closure? What makes a closure? What's the trigger? Return a function. Oh, now it stops working. Come on. There we go. Okay. This function's purpose is going to be simply to log the players on the team. So we're going to console.log, team name, comma, players. We're going to log the team name and the players. We've created a closure. There's not a lot of code there. We've created something that will give us a closure. So I want you to see that's the pattern, but it doesn't help answer the why. That is the what. The why is how we use it to our advantage. We took the time, we understood how this works, we set up a structure that uses those concepts. So now we can use it. var, what's a Quidditch team name? Hufflepuff. We get Hufflepuff by registering a team. Team name was Hufflepuff. Hufflepuff needs players. Oh, hold on. We missed one thing here. Brain fart. This function needs to take in a new player. This function's purpose is to add a new player. Players.add new player. There we go. Now we have a way to add players. So, this isn't the Hufflepuff team. This is the Hufflepuff add player fn. Fn for function. So I know it's a function. And that's really long to type. It reads great in English. I know what it is. So I'm going to copy paste. Hufflepuff add player fn. It needs a player on its team. Who wants to be on Hufflepuff? Say your name. Nobody. No one else. The lonely nobody. And if players.push. let's walk through this. We called register team. We passed in Hufflepuff that came in as the team name. It basically set it up a var for us, right? Off of this thing that was passed in. We have a var. Then we created our own var players. It's an array. Then we said, hey, cool, we know about Hufflepuff. If you want to add players to the team, here's a function you can invoke every time you want to add someone. This gets slurped up, packaged down, kicked out. It was returned. So it comes out of here, flies to the left. We're catching it in a variable. So it goes through the equal sign, and we get this function right here. So if we invoke it, we push the button, we're pushing the button on this function. This is the code that runs. We give it nobody. Nobody comes in as a new player. We push them into our players array, and we log them. We log team name Hufflepuff and the array, everybody that's on the team. We invoked this function 3 times. We added nobody, and then it got logged. Then we invoke it with no one else. We push in no one else. It gets logged, and we get Hufflepuff with nobody and no one else. We call it a 3rd time. We give it the lonely nobody. Comes in here as new player. We add new player to the players array. And then we log Hufflepuff and all 3 people. Watch what happens if I simply move players. You're like, well, it's inside this function. What if we put players here in this function that we returned? Keep it all together. Watch what happens to the log. Notice we have nobody. We have all 3 team members correctly. If I run, think in your head for a second what you think the outcome's going to be. What's going to get logged? Run through this in your head. We're going to log each person individually 1 by 1. Why? Why does this not work, but players up above works? Yeah. I invoked Hufflepuff, add player, nobody. It comes in here. Players is an empty array. Add them, put them on a team. Invoke it again. No one else. Players is an empty array. Let's start over. There's no one there to keep track of what's going on in between each function call. So that doesn't work.
So like if you were to take this, makes like something like a YMCA or whatever, how like it's a little league, you could input players in like your team name. You would make a generic function like that, register team, and it would iterate that.
Wait until my next example. We're going to go more complex. Right now we're keeping it simple. Okay? We're going to go a little more complex for the next one that will hopefully help you see even deeper how this can be a tool. Yeah, that's basically what we said. By returning a function, we're saying, hey, we're going to set up an environment, a playground, a sandbox for this invocation. Boom, sandbox right there on the playground. Here's how you get to that sandbox. We invoke register team again. What's another Quidditch team? I like that. Slytherin. Register team. Slytherin. Who wants to be, we'll just call this one Slytherin FN. It's the add player thing, but I am a programmer and I'm lazy and that's a lot to type. You asked too much typing. Ugh. Okay. Who wants to be on Slytherin? Say your name. Lane. Jackson. Miguel. Okay. If I run this, what's the output going to be? How many times am I going to get an output? How many times are we going to get a log? 6, because we call this function 1, 2, 3, 4, 5, 6 times. So this console log is going to fire 6 times. What is the first log going to be? When I call this one? Hufflepuff, nobody. What is the second log going to be? Hufflepuff, nobody, and no one else. This one is going to be Hufflepuff, nobody, no one else, lonely nobody. Then we're going to call it here. What is the log going to be? Slytherin Lane. Then we're going to get Slytherin Lane Jackson, Slytherin Lane Miguel. This is a very tiny piece of code. If you take out curly braces, we literally have a variable name, an array, a push to an array, and a log. But by making something that simple and understanding JavaScript and closures, what we've created is a simple way to register as many teams as we want and keep track of all of their players separately. We don't have a way to do that right now. We don't have a way to just access the array. The only way we have is to add a new player. Next example, we're going to show you that, how to take that up. Great question, though. It's a good segue. Okay, so when we call register team, we pass in this argument to become team name, right? So this function, it's not invoking register team. It's invoking this function. So it works just like any other function in that you pass in a parameter and it becomes the first parameter of the function. It might help, and we can do this, if we name this. These are doing the exact same thing. We registered a team, we created an array of players, we created a function that we can use to add a new player, and then we returned that function out. We said, hey, what you're getting is this add player function for this closure or this snapshot. I invoked register team twice, so 2 different copies of add player were returned. A copy with the playground in the world of Hufflepuff, and a copy with a playground in the world of Slytherin. Segue. You guys are like trying to push deeper, and that's where we're going next. Okay, I'm going to save this and share this in Slack right now so I don't accidentally delete it and have to retype it again. Yeah. I wanted you guys to have it. I felt bad that I had deleted it. So, okay, there is basic closure with Quidditch teams. All right. Gonna go make a new one. All right. So, neat that we can do that. Now, we're gonna go a little deeper and do something a little bigger. Something right there, that was basic. Now we're gonna go, and I want you guys to attempt this. And I'm simply gonna help you set up a basic structure. Function, make calculator, start num. It's going to return an object with add, subtract, multiply, and divide on it. I expect to be able to call make calculator multiple times. Otherwise, closures lesson would be pointless. We'll just do it twice. So I start with 3 and I start with 5. I'm going to need to be able to keep the calculator, keep each calculator, and do the calculator operations. Try this. You can team up as long as you're not letting someone else just give you the answer, as long as it's helping you understand and dive deeper. I guess the last hint I'll give you is these are verbs. If you remember what verbs should be in JavaScript, should give you a hint of what kinds of things need to go in these spaces. It doesn't matter. It's a calculator. You should be able to do whatever you need. I want to add 7. You want to add 20. Just the start, and I'm like that. This is not complete. So as I said, you're going to need to keep each calculator and do the calculator operations.
When you run a 3 into it, what are we trying to get out of it? Like, I don't understand this. Yeah.
Okay. Let's go a little further then, and then we'll let you practice repeating a little more than that. All right, so when I make the calculator, I'm going to have to catch it. I was trying to give you hints to practice this. Now on Calc 1, I can add 7, and then Calc 1, subtract 2. And I could do the same thing here, var Calc 2 dot multiply by 8, Calc 2 dot divide by 4. This is the end game goal. I made a calculator. I started with 3. I added 7. I get 10. I subtract 2. I get 8. This guy should have a value of 8. Started with 5. 5 times 8 is 40. 40 divided by 4 is 10. I have made Calc 1 and Calc 2. That's my end game goal. I can make a calculator. I can call add. I can call subtract. I can call multiply and divide. And you've used a calculator. If I have a number in there and I do plus, it keeps it, and then I can hit plus again, and then I can hit minus, and I keep a rolling total of what the value should be off of doing all these operations. That's the end game goal. So let's work backwards and let's do add. Add is a verb, therefore it needs to be a function. Function add. You look right here, add, did I take in any parameters? When I called add, yes. I took in a num to add. And here's my starting num. And so this var total equals start num. So if I wanted to add, total equals total plus the num to add. It's just a basic add. And I can return my add function right here. To make it easier, I'm going to call this addition. I'm going to return addition. We could put the function right here inline, yes.
Is it just more confusing that way?
Some people get lost sometimes, yeah. So this makes it very explicit what's going on. So I did add, tried to do the subtraction function, the multiplication function, and the divide function, following this exact same pattern. Okay. Let's walk through this. If you struggled or didn't complete, that's fine. That's good. Hopefully you didn't just straight give up, though. Hopefully you at least were trying to think and process this and get the brain churning around how this could be done. I don't expect you. We just went through a crash course lecture on one of the most confusing abstract concepts in the JavaScript engine. You might not be masters yet. Newsflash. It's okay. It's fine. But the struggle is real. The struggle is how you build strength. The struggle is how you start to be able to make connections. This was intentionally supposed to be a little painful because through pain comes learning. Through struggle comes growth. So, if we follow the same pattern, we're going to need a function for subtraction. Num to subtract. We're going to need a function, multiplication, with a num to multiply. And we're going to need a function. We'll put this one down here because someone asked if you could. For divide, we're just going to put our function here, num to divide. Follow the same pattern, and I'll put these inside of here. So, what do we do in subtraction? Total equals total minus num to subtract. What do we do here? In multiplication. And what do we do down here inside of the divide? I put it here just to show you that you could do the functions inline on the object, or you can do them separate and reference them by name to pass them in. Both work. Both are valid. They're both valid patterns for JavaScript. You could use plus equals, minus equals, etc. Yeah. Okay. That's neat. How do we know if it worked? We need to add one more. We'll just call it log. It's a function, and it does a console.log of total. calc1.log, calc2.log. We added a log function, and then we just used it on each calculator. We hit run. We see 8, and then cal2 is not defined because it's called calc2. We see 8 and then 10. And that's what we calculated it should be. There's nothing left of this. It doesn't return anything. If I did var calc return, and then a console.log of calc return, call this return undefined. My add returned undefined. It didn't return anything. You're right. There is no return. So how does it keep track of that number going through multiple calls? We started with 3. Start num. We added 7. We subtracted 2. That got us 8. When we logged it, we got 8. It worked. How? How does this call to add and then this call to subtract share a number? because of closures. That is the correct answer, but does that really, right? That's what we're learning today. That's what we're leading to. What's happening is what we drew here on the board in the beginning. Our parent is make calculator. We took in a start num. It gave us a closure for that calculator with total. We made var total. It lives in the parent. So now it doesn't matter that there's one child or the fact that we have 5 in this one. They're all functions with the same parent, so they all live in that same closure. They were all returned with the same return statement. So we get one closure, except we don't just have fn7, we have add, subtract, multiply, delete, and log. And all of those share the same parent with total.
So the total is the inner functions are able to access the outer functions total.
Yes, scope. With scope in JavaScript, we walk up the tree to get variables. I call make calculator. I pass in 3. 3 comes in as start num. Total equals start num, so total is 3, because that's what was passed in right here. Then I create functions. Do any of these run right now? No, we never pushed the button. We just said these exist. These are instructions you can use later. Then we return an object that's pointing at addition, subtraction, multiplication, divide, and log. This guy returned an object that has properties to do those 5 things. That leaves and comes here in Calc 1. So we came in here, we set a total, and we made a whole bunch of functions and put them on an object and did absolutely nothing else. We just set it up. Now we call calc1.add. Comes into this object that got returned. Calc1 is this object. But we returned something with a function. So we got a... What do you get when you return a function? What gets made? A closure. So this is calc closure 1. Not just calc 1, a copy, a snapshot of all of this, including start num and total. So we have a snapshot over all of that. We add 7. It comes into add, says we're using addition. Num to add is what? What do we pass in? 7. We called add and gave it 7, so our num to add is 7. What is total? 3. 3 plus 7 is 10. Now total is 10, which lived in the parent. So the old value of 3 is gone, and now 10 exists inside of this closure. Inside of this closure, this calc 1 closure. Underneath, this calc closure 1 copied this whole thing with its variables and its scope and its functions and everything. Then we called subtract. Pass in 2. Comes into subtract. Finds the subtraction function. Total is what? Well, let's... Subtraction, do you have total? No. So let's go ask your parent. Parent, do you have total? Yes. What is total right now? 10. So 10 minus 2 is 8. Set that equal to this total. Parent, your new total is 8. It is no longer 10. We repeat the exact same steps, but we make a new calculator. except this one gets a different closure. So calc closure 1 has a total of 8. We make calc closure 2, it gets a start num of 5, and its total is 5. We follow the same steps, except for we do have two totals. We have the total in closure 1 and the total in closure 2. They're separate and different, so we can modify them separate and different. So we can, at the end here, calc closure 2 and calc closure 1, we'll just log them both. 8 and then 10 and then 8. So we get rid of this. We're at the very bottom. We've gone through all the operations. Calc closure 2 has a value of 10, and calc closure 1 has a value of 8. Scope tree snapshot. 2 different snapshots, 2 different scope trees, 2 different totals. Could we make another calculator? Yes, then we get another closure, another snapshot.
Now, if you want to access and use total.
If I want to access and use total.
Yeah.
So right now, all I can do is log it. I'm going to stall. I want to take a break soon because I can tell we're near saturation. So I'm going to stall that till after. How to access and use total. Okay? I wrote it down. We won't miss it. Did you have a question? Someone back here? Okay. Okay. Take a break. Let the brain unwind a little bit. Ponder questions, things that are confusing. Come back and we'll do a follow-up Q&A. What questions do you have? What questions and or notes do you have?
Is there a different way to log that? Like, you have to log it, I guess because you're returning it right there, you have to log it in that return.
So I did it here as a log because I'm inside this function, so I can access the parent total and actually log it. Which is a good segue to his question before, how to access and use total. I'm going to answer that question by not answering that question. Give me a second. I'm going to answer it with a question. Should we allow people outside of here to access and use total? He says no. You don't want it to be what? Yeah, you don't want it to be yes. He's just got to be a rebel, no to everything, right? No. So, this is a deep programming thing. You're going to work on a team with people. Whenever you expose a variable that is tied deeply into a lot of machinations, a lot of moving parts, you are exposing a boatload of trust to other developers. A lot of trust. Because what if I could access total anyway, just straight up access it, and somewhere in my code are like, oh yeah, I'm using the calculator, and now total is 30. Does the calculator work the way it's supposed to? No, because the programmer added 30 randomly instead of the user telling it what to add. Calculator example is pretty terrible for that, right? But real life example where someone else broke my stuff. I was writing a component for the front end of the web. I was doing some neat stuff on the page. I had to calculate widths and heights and all these other things, and I exposed my width. Everything was fine for like 6 months. Another programmer was like, oh, hey, you got this? I'm going to use it. Brings in my code. That's a good thing. He doesn't have to write it. He wants to share. But he goes, oh, my stuff needs to work a little different. And instead of coming in and writing a function or things to make his code work a little different, he did it on the outside. He accessed my variable, and he started messing with my widths. He ships his stuff. Bosses are happy. His stuff works great. All of a sudden, I get a bug in my stuff that my stuff is jacked up Because he totally messed with my assumptions of how I was treating width. And it broke my stuff. And so we had to come back together, and I had to be like, no, dude, you can't do that because you're messing up my stuff. I understand how this works. I see what you need. I'm going to go add this functionality in so that I can use it my way, and you can use 90% of the stuff with your 10% tweak, and we're both happy, and we both can use it our ways. So by exposing total and things like that, you introduce risk of someone coming in, another programmer in specific, and breaking your stuff. So much so that there's a pattern for this. We talked a little bit. This is encapsulation. In JavaScript, this specifically here is what is called the module pattern. If anyone asks you, hey, do you know any patterns in JavaScript? Today, you learned the module pattern. We have created a self-contained module where we have said total is private. It's mine. No one can see it or access it but me. If you want to use me, you have to go through my pathways. There is no other way for you to get to total. I'm in full control. This is my module. The module pattern is creating variables that are private and then properties that are public via the return. Outsiders can access what you tell them. Whatever you return, that's what they can access and nothing else. Outsider could not directly invoke addition. They have to go through add. An outsider cannot access total. They have to go through one of these to manipulate the total or log the total. I maybe would, if this was a real calculator, sure, I'll add a function that returns total so they can get to it if they want. They don't want to log it, but they want the number. I'm okay with that. But I don't want them changing it except one of these four ways. Because I have a basic calculator for Sesame Street. Don't want to break 5-year-olds. It's messy.
So with the return statement, you call get total, you can then access that number, use it other places down the line.
Uh-huh.
And they still don't have access to your functions. They don't have access to your code.
Correct. So right here, get total. This is going to be current calc1 total at that exact time that I invoke the function. Now, if I did more stuff and invoked it again, I'd get a different number. I only got the number at that exact time. So, can you expose this? You really don't want to for this pattern.
But you can return, that's okay.
Yeah, sure. You're the programmer. You have all power, right? The reality is you just barely got thrown in the water. You're learning the swimming techniques. You really got to master those before we can get into the deeper details of this is why you do front stroke at this time, and this is why you do backstroke at this time. JavaScript is a loose set of rules for how the engine interprets your code. It is nothing more. The whys, the patterns, the hows, what you can do, you're a programmer. If you can think it, you can do it. So then the questions become, is this maintainable code? What are the odds of this breaking on me in the future? What are the odds of someone else working in this code breaking it on me and making me have to go fix their bugs? So if you can think, so I asked this question, do I have a good reason to give them this total? Yeah, it's a calculator. They can write all sorts of code to want the total. I'm going to give it to them. Do I have good reason to let them mess with it any way they want? No, sorry, I don't trust you that much. This code is perfect, and you could break it if I let you do other things. So I'm going to only let you do things my way, and that helps me ensure this code stays perfect. So this is a patterns question, how to access total. So I will finish answering the question, though. If you really decided, if you're going in here, you're the programmer, you do what you want, you're like, no, I'm okay if they manipulate this variable directly. I don't care. Do you think this will work? No, because it's going to grab the value of total at the time of the return. So it'll just be the start num and then never change. This will get replaced with 3, and that's what gets returned. So if you want them to change it, this is called the get set pattern. When you restrict access and you lock it down, you do a closure, you give them a way to get the value of a variable, and you give them a way to set the value of a variable. Just taking a new total, and I change it for them. So they can do whatever they want now. They can ask for the total, they can add, they can subtract, they can multiply, they can log, and if they really want to, they can call set total, give me a new number, and I'll overwrite the current value with whatever they gave me. If you really want them to access and modify total in this pattern, you need 2 functions, one to get and one to set. Well, there are other ways to do this, but this is the most straightforward. This is the only one I'm showing you right now. Most of you are already like, okay. Other questions? All right, I'm going to save this, share it now. Start a new one. All right. I will add this disclaimer for those here that are frustrated. I've been programming, before I came here, I've been programming 9.5 years. Learning closures took me a few weeks to really start to feel comfortable with them. Even after coding for like 8 years when I started learning them. It's an abstract topic. You have to teach yourself how to have the setup and then the clone and the copy and the maintaining. That's okay, right? We teach it now, though, so that you can start processing it and so that we can reference it in the future. We totally have a chicken egg thing. I really wish I could show you, because I think a lot of you, the second you start seeing why, a lot of these things will click. I really wish I could throw you into the deep, serious code where this solves a real problem in a clean way, but you're not even ready for that. I would crush you if I tried to do that right now. So we have to do it. This is the best way I've found. We have to do it the slow and kind of painful way, where we have to take these abstract topics, these challenging things, introduce you to them to kind of let you get your feet wet a little bit. But we don't expect you to be able to swim in these, so that later when we get deeper, you can hopefully have some technique to learn to start swimming when it applies and clicks. I've had lots of students, especially when we get into Angular and web requests and other things, there's some really great examples that can only be solved with a closure. But we're not there yet. And I have students that are like, I didn't get closures until you told me to try this thing. I tried this thing, and now I get closures. So practice these, learn them the best you can, but closures should not be a source of discouragement. The same fundamentals apply. For loops, if statements, objects, arrays, variables, functions. Returning functions inside of functions, you need to be comfortable with that. The whole closure aspect that goes with it, I'm okay if you're fuzzy on that after today. I'm okay with that. But understand you're going to need to come back and relearn these things later to really call yourself a JavaScript dev. Okay. Now we're going to talk about prototypes. Good news. Prototypes are a lot simpler to understand than closures were. Way simpler. We're going to do prototypes pretty quick. Prototypes are neat. They're a neat way to share functions. I'm going to use a very familiar example. I hope it's familiar. I hope you remember yesterday. If you didn't remember this, please Slack me and tell me that I'm just so terrible that you're spacing out my lectures and you didn't remember this part out of yesterday. Then I can try to be better. So, we've got an animal. This dot type equals type. This dot legs equals legs. This dot sound equals sound. And then yesterday we did this. This dot make sound is a function that logs the typing furiously. The giraffe has 4 legs and makes a large bleeding goat sound. Does this look familiar? Anyone remember what this pattern's called? Constructor functions. Constructor pattern, yes. Vocab word. If you didn't say that out loud and you didn't remember it, say it in your head 3 times really fast. Constructor, function, constructor, function, constructor, function. This is one of the more common and easiest to get into JavaScript patterns. If you ever need to make an object more than once for any of our projects, do this way. Is it the best way? No, but it's great practice, and it's better than just making them inline and copy-paste. Is it always the right fit? No, we'll give you other tools. But this is one that you can practice, and when employers see stuff like this in your code, they are impressed that you understand some other routines and way to reuse code and way to share functionality. Cool, we made one animal. We got 1 copy of each of these things and 1 copy of make sound. If I go through and make 1,000 animals, I'm writing an app to manage all the animals in all the zoos across the country. And they all get names and languages and types and origins and home cities. And there's all sorts of things I can do with these. I have 8 functions in here to deal with animals in a zoo. Do I want 1,000 copies? Do I need 1,000 copies of make sound? No. This comes back to a memory thing. This is why it exists. On your computer, the only way you're probably ever going to max out your memory is one of two ways. Anyone know? One way to max out a computer's memory and make it lock and freeze forever? Or a browser? An endless loop is one of them. If you write a for loop that never ends, you crash Chrome. Congrats. Do it sometime. It's kind of fun. But make sure you save any other tabs or things you want first, because they'll all die. Second way, we already talked about it earlier this class. Out of memory. Running your app out of memory. The endless loop locks it down because it's literally stuck. It doesn't know how to process anything else, including mouse clicks. It's just stuck there forever. An out of memory exception will crash it because it's trying to put variables in memory and goes, we're out. I can't keep going. Kill all the things. It might seem dramatic, but it's how it works. Because it doesn't know what to do. You had needed it to do this thing, and it couldn't. Therefore, it can't ensure that things are going to be in a good state, so it just kills itself. So, memory. If we copy this function, right now it's only a console log. But there's no reason that this function wouldn't have if statements and for loops and another if statement and a log and an else and an if. I'm just filling this up with made-up code, right? I'm pro programmer, guys. Learn from me. Whee! Okay, so this is a real function. This is closer to reality. It's actually a function that does something useful. In quotes. Use your imaginations. So what if I copy this 1,000 times? Do you see how we're getting closer and closer to the point where it's like, wow, that seems like a waste of memory? You are probably, without a memory leak, never going to crash someone's browser. Even doing this. because you've got like a whole bloody gig of RAM that Chrome can get to for your app, right? Like, unless you're doing some crazy 3D graphics, storing tons of data, you're not going to crash it. But you could very easily crash one of these just by writing less performant code. My phone does not get a gig of RAM for Chrome. My phone doesn't even have a gig of RAM for everything. So if you understand that, now you kind of hopefully see the main why of prototypes. They are a way, and I'm going to show you how we do that, to share this one function, one copy for every animal. And it's really easy to do. I'm going to take that out. Outside of the function, animal. That's the name of my function. Dot prototype. Hey, we're learning about prototypes. The keyword is prototype. That makes it easy. Dot make sound is a function. You're done. I'm going to get rid of the garbage code that doesn't work so that I can show you the code that does work, because I can say giraffe.makeSound, run it, and I get the giraffe says that. So this is a function. We gave it some setup instructions using this. Prototype is another way to do setup instructions. Except all it is saying is whenever anyone makes a new animal, make a link, make a temporary property called makeSound that knows how to get back to this function and run it. So there's only this one copy of makeSound. We go make 1,000 animals, and on each one we invoke makeSound 1,000 times. Besides getting a headache from listening to that many animal sounds, we are confident that we only have that one copy of the function. We saved memory.
So, like was said earlier, I'm just curious, if you go to the constructor function and you make sound, you have to make several different sounds for each animal within that constructor function, correct? So that's why we use prototype, right?
So, close. You're very close. So the part I think you're missing is we go to the constructor function not one time, but 1,000 times. We make 1,000 different animals. So it's not that we need to make sound in here multiple times. This dot memory, or let's see, 1,000 copies make sound. I make this, I can make the sound, do whatever I want in there, but if I make 1,000 animals, I get 1,000 copies of this function in my memory. On the prototype, I have one copy. Doesn't matter how many animals I make. I can make 1, I can make 5, I can make 1,000. I have one copy of make sound in my memory. So I just saved a boatload of memory, a humongous amount. Especially if that function was big, like I showed you, doing a lot of things. One advantage of this pattern is because it's on the prototype of animal, I can only get to it through an animal. So I can only get to it via implicit binding that we learned yesterday. I will only be able to call one copy make sound if there is an animal left of the period. So this will always be the exact animal that's trying to make the sound. We can use this to get to all the data. I was going to show you this yesterday, but your faces told me not to. So I know it fits better yesterday. You wouldn't want to. If you're using prototypes, well, yeah. Well, as long as you're not binding this exact function to something else, you're okay. Because this exact function will always have an animal left to the period. Why? Because it's on the prototype of animal. That's it. Know how to make can you type the name of the function, dot prototype, a function name, and then do your function? Did you understand this context yesterday to realize, oh, hey, implicit binding, I'm getting the animal? You know how to make a prototype. I told you, we get that way faster than closures. I do want to show you a second really good use case. This is a great use case. If you have an entity, a user, a product, etc., and you want to start manipulating things on that, doing this pattern will impress employers. It will, I promise. There is another really good use for this because of how this works. Every object in JavaScript, and everything in JavaScript is an object. Therefore, every variable you ever make, every function, well, not every variable, primitive types don't. Every object you ever make, objects, functions for sure, and arrays, has a prototype you can attach stuff to. Because here we're attaching to this function that hasn't been run yet. We created it, and then we said, oh, extra definitions, these are on the prototype. These ones are meant to be shared. So we can attach to anything we want. Like array. Array dot prototype dot get jiggy with it. I don't know why Will Smith's in my head, but he is. Okay. So I attach this function, and I'm going to console log get jiggy with it. Var my array is an array. My array dot get jiggy with it. Run. I renamed it. My giraffe says bleak, and then get jiggy with it. Every array I make in my app will have access to the get jiggy with it function. Every array. Why? Because I now said the array parent itself, this is where this comes from, on its prototype that it's going to give to every array that's ever made, has this function. This is a terrible example, because why would an array want to get jiggy with it? Right? So, what if we wanted a get all evens? We wanted a function that knew how to get all even numbers currently in the array and give me a new array. There could be use for that. What if I wanted to quickly just sum the total of everything in the array, assuming it's a number? And I don't want to write a for loop to count them again. I've summed this in 5 places. I'm going to write a sum function. This is going to talk to what is left of the dot, or the array itself. So I can say var my array is this. Write a for loop. For var I equals 0, I is less than array.length, I plus plus. Huh? And you get the point. I could go in and find the evens, put them in an array, and return it out. I could sum them. I could divide them all by 3. Right? Like, I could add taxes. Let's say I have an array of prices, and I want to get them all with taxes applied. Could write an add taxes prototype. And now I don't have to make a new special construct. I can just do it on any array.
So the array with capital A isn't a constructor function that was previously.
It is. This is a shortcut they added in JavaScript so that you didn't have to do this anymore. This is how you used to have to make an array in JavaScript. But programmers are lazy. And they said, we make arrays all day. This is annoying. Let's put this in there that knows how to do that new array for you. Same thing with an object. An object is really calling the new object constructor function for you.
So that constructor function is like part of the window.
It's part of JavaScript language itself. Yep. If you have JavaScript questions, for me, if I have a JavaScript question, I always prefix my Google queries with MDN, Mozilla Developer Network. Maybe it's just me, but I feel like they have some of the best documentation for JavaScript out there, period. Because they almost always have a ton of examples, and that's what I love seeing. See it used 5, 6, 7 different ways, and it's easier for my brain to start picking out patterns. So, MDN array. If we look here on the left, different methods you can use on arrays. From is array of. You probably haven't used those yet. We can gloss over that. But then, let's get into this. Array.prototype.push. Anyone ever use push on an array? It's because it existed on the prototype. Why? Because you're going to make hundreds of arrays in your app, and they wanted to share that push code so that they didn't duplicate it. Almost everything that you use in JavaScript off of arrays or objects, any built-in function, is probably a prototype for efficiency. And you have the power to add this exact same functionality. Push, pop, join, keys, find, filter, concat, reduce, shift, slice, splice, toString. How many of those sounded super familiar? They should. They really should. So, this should be your nighttime reading. Learning these prototypes on the built-in functions will help you solve so many problems, I promise you. There's code you're going to go write, and you're going to learn, oh, there's a built-in function that will do that in one line and get rid of these 10. Oh, why didn't I know that? Because you didn't read MDN before bed. Right? It will also help you wind down and go to sleep. Right? Maybe it'll get you excited, like, oh, I got to go try that in code. I don't know. So, arrays, objects have prototypes. I'm going to go back here. Object. Right there, here's all the object prototypes. Has own property, toString, watch, unwatch, values, keys. I guess there's no keys, just value. Yep, there it is. You've been using prototypes this whole time and didn't even know it. Today you know. Last thing I'm going to show you. This is a fun and silly open source library someone made. It's a JavaScript library where you can do anything you want. It's literally a bunch of random functions and prototypes people have created to do the silliest things. Why would I show you this? It can be fun, creativity. Sometimes you just need a little fun to pull you in to be interested in things, right? It's just why in a couple weeks you're going to do your own first server project where there's very loose guidelines. And so you get to kind of flex your creativity, and it really helps kind of pull people in to be more invested and excited. The other reason, though, that I show you this is an open source library. Meaning, you could go write a function that did whatever you wanted it, make a pull request, submit it, and as long as it doesn't, there are rules, like you can't break someone's code, you can't be obscene, things like that. But other than that, you could get a pull request approved, and you could technically not lie and say, I've contributed to an open source project. The second reason I show you this, it's probably the easiest open source projects to get something in, because you just have to make something that doesn't break other people's stuff and isn't rude, and they'll approve it, and you contributed to open source. All right, any further questions on prototypes? Any notes on prototypes? Yes. Oh my gosh. Okay. Not bad. All right, we're going to be officially done with this lecture today, done with closures and prototypes. If you want to go start working, you are free to do so. I really want you guys to get JavaScript, though. So if you're fuzzy on anything, you could use reviews on anything. I'm going to stick around for another hour just to kind of do like a review, refresher session on anything, questions, topics people might have. But if you're ready to go practice and you want to go practice, go ahead and go in the other room. If you have questions or want to review, stay here and we can do something like that. Will you post that in Slack in your DM13 channel just so that those walked out can have it too? That is a pretty detailed list of what's on this assessment. And hopefully as you're going through it, you're like, I'm moderately comfortable with at least some of that, right? It's not an extreme test. You'll notice there was no closure, there's no context, there's no this, there's no closures, there's none of that.
Similar to the code card practice.
If you can go through all the code cardio practice things and finish the assignments in the projects in the afternoon, Friday and Monday, you should have pretty reasonable confidence in yourself to be able to complete this. If you actually understand what's going on from Friday and Monday and the projects we gave you, there aren't surprises. I'm not a fan of surprises. I don't want to test you to know something I didn't teach you. That's not fair. That sends a bad message, I think. I want you to trust us that we're teaching you the things you need to know, so I'm going to test you on the things we've taught you and asked you to practice.
When you say using objects to count things, methods?
No. Oh man, I can't write. I'll show you what I mean with that. Anything else someone want to put on there?
I have a problem in utility products. If that's
Okay, I already know this is more than we can cover in an hour. We're going to cover what we can. We're actually down to 40 minutes. I'm not going to keep you past 12:30. Brains don't work without food. They need glucose. So definitely by 12:30, but I will see about having Brett or myself or someone come up and do another review, or maybe one of your mentors this afternoon to try to go through more of this list. And we can do another one tomorrow afternoon too to help you guys kind of really get this, okay? All right, so I'm going to start with the fundamentals. So as far as examples of closures, I'm not going to cover that. There are practice problems that go through a lot of different examples. All right, so we've got objects and arrays, looping through objects, arrays, counting objects. Seems to be the biggest trend. So I think that's where we're going to start. Cover most people's concerns going over objects and arrays, how to interact with them and deal with them. All right. Hopefully because of the lectures Monday, did Brett do a good job Monday? Yeah? Good. Hopefully because of that, we can rehash his 60 to 90 minute lectures down into 10 to 20 minutes to go through these. See what we can do. Objects and arrays are both containers. Their job is to help you store information in multiples. If we needed to store one thing, we don't need an object or an array. We just store the one thing. So objects and arrays are the solution for when we need to store multiple things. Objects have two primary use cases that I like to teach for when to use an object. The first, you have a single entity with multiple properties about it. I have a person object. What do I want to track about this guy right here? Hair, height, weight, eye color. Pull out a driver's license and you've got a half a dozen to a dozen things that you're tracking about an entity right there. One person, multiple attributes to that person. That is the perfect use case for an object. Because I can make a person object, give him eye, hair, height, weight, etc. And now I can access that person object to get that guy's height, that guy's hair, that guy's weight, that guy's eyes. All the thing about that one real-life entity is stored on that object. This is the core of what you're doing with data in JavaScript. You are not writing code to make a computer happy. I mean, we want to do that because then it works. Why do we write code at its core? Because there is a real-life problem that ain't nobody got time for. Something in real life is happening, and you want to write code to solve a problem. Something that people are bad at. Could you send out 40,000 emails? Yes. Does anyone here want to? So that's where a computer's great. We write code, it'll send out 40,000 emails for us in seconds versus the days or weeks it would take us to do it manually. Computers solved a problem. To be able to solve problems, though, we have to figure out how to take a real-world problem and represent it in the code. This process is called modeling. Like a model airplane. Can you climb on a model airplane and fly to Tahiti? In my dreams. But the model airplane is small enough and contains enough representation of a larger one to give us an idea of what it's like. We do the same thing in code. We try to take the real-world problem and identify which pieces of information we need to track in the computer to be able to solve the problem in real life. I could put in every single piece of information that I possibly wanted about this guy. I could detail the length and curvature of every hair on his arm and his head. I could put in his DNA sample. I could put in everything possible, but I still couldn't clone him. I still am only going to have a model, a representation of the real him. The same thing happens with any problem. You can get all the information you want, you're still only modeling or representing the real problem. So we need to do that, and objects are great to identify a single entity in the real world. A person, lots of things to track. A team, lots of things to track. A business, address, email, secretary, CEO. Products, price, description, color, height, or size, etc. Taxes. All the information you had to fill out for your taxes somewhere. What are all the information the IRS needs for you to file your taxes? Etc., etc., etc. Name anything in the real world, and you could start pulling out properties of information and track them in a computer. And people do. They track information on their dogs, their hobbies, their sports, their fun, their problems, their diaries, their meditations, their medical issues. Almost anything any person ever does, someone has tried to track in an app somewhere. This is where we're at. Track all the things. So, objects are great for a single entity, a product. These are the properties of a product we want to keep, that we need to track to be able to solve our problem in our app. The second use case for objects becomes clearer when you stop and think about the difference between an object and an array. An object is what is called an unordered list, or a hash. An unindexed list is more appropriate. An array is an indexed list. What does that mean? I use the keyword index on purpose. Huh? It means there's order. My array has indexes. If I access index 3, I expect to get to that spot every time. And I expect what I put at spot 3 will always be there if I come back for it. In an object, How do we store things? It's not by index, it's by properties, property names, keys. So an array is simply a way to say I've got lots of things, spot 0, spot 1, spot 2, spot 3, etc. You can easily add more to the bottom, you can take them out, you can loop through them in order. It's an ordered indexed collection of information. Could I put the exact same information on an object that I could in an array? It's just a collection of information, absolutely. The difference is, with an object, I don't get the indexes. I have to make them up. That's it. I have to do more manual work if I wanted everything out of an array, an object that I get out of an array. I got code. We'll do code. So let's do a list of products. So if we do it as an array, again, object that has a name. We're going to buy shoes today. And color, they are red. And price, really expensive. Make another one real fast. Okay, I have a really basic array. I could take these, put them as an object. Same information. I literally was able to copy paste it, add the property names in a comma, and I'm done. I have an object with a name, a color, and a price. I have a shirt with a name, a color, and price. And on my products objects, I have shoes with a name, a color, and a price, and a shirt with a name, and a color, and a price. Here, I say products index 0 and products index 1. But down here, I say products object dot shoes and products object dot shirt. It's the exact same information. Here, they did the 0 and the 1 for me. And down here, I had to give them variable names, property names or keys to know how to access them. I think it just logs this very bottom one is all it's trying to do, but I didn't log anything, so it's not going to show anything by running. They're both containers. They can both store information. When we have that fundamental established, we can start getting into the nuances of their differences and how they can be used for or against us, to help, hopefully to help us, right? So here, auto building number starts at 0, just gets larger as we add things. This, we have to specifically give it the key. Differences. The array, it's ordered, and it's sorted, and it automatically gets bigger, because I can just do dot push and add a new product. It's great for managing flexible, large, growing numbers of things that get bigger or smaller. I'm going to add. I don't have to do a lot of work. For loops are really easy, are a lot easier with arrays, because you can just go off of the length of the array. Know how many are in there. For var I equals 0, well, I is less than products dot length products plus plus. So I'm going to products index I. I is going to be 0, and then I will be 1, and then I will be 2. No, I won't be 2 because I only have 2 things in there. I automatically know to be done. Instead of what? Oh, you're right. Typo. Good catch. Newsflash, you code for 10 years, you'll still write bugs. You'll never get out of writing bugs, even the best. Especially when you're trying to talk and type and think at the same time, and you're male, and you're good at doing one thing at a time, trying to do 3, bugs happen. Yep, I++. Good catch. Looping over an object, we don't have any way to know how many properties there are. We can't simply say and we don't know what they're called. We can't just access them by a number. They're called shoes and shirt. JavaScript has no idea that we're writing an object about clothing products. So we need to instead tell it to spit out the names of the properties that are on that object for us. For var property name in products object. That is going to go through the products object, find the property name, and give it to us as the property name. Oh, hey, you've got something on there called shoes. It's actually speaking in computer, so it's like you've got SHOES, the string, I don't know what it is. The primary way to use that is to access the values of an object dynamically. How do we do that? There are 2 notations for accessing properties on objects. They are dot notation, square bracket notation. Dot notation, right here, product obj dot shoes. Product obj dot shirt. Great. That is dot notation. But can I do products obj dot property name? Yes. Doesn't work the way we want it to. But I can. It's going to go, hey, products obj, do you have something called property name? Look here. Does it have something called property name? No. So it goes, undefined. Here you go. It's undefined. You want a property name? No one has defined property name. You get undefined. Every time. That's where square bracket notation comes into play. Because with square bracket notation, it doesn't use property name. It opens the box that says property name, gets the value inside of it, which is shoes, and basically looks for products obj dot shoes. Dot notation assumes you know the exact label name. Square bracket notation assumes the label name is in the box with the label you're giving it. So it needs to take what you give it, property name, open the box, get the real label out, the value, and use that to do dot notation. So it's going to loop through here, products obj. Give me the first property name. It's shoes. Products object. Look for property name or shoes. And it finds shoes. Then it loops back through. Give me the next property name. Next property name is shirt. Well, don't actually look for this label. Look for the value behind this label or shirt.
So if you wanted to access the value in not a property name, could you do just use parentheses also and just use the object name and then square bracket and property name?
So I could hard code this like this. It's taking a string. Shoes. Great, it'll go find a property called shoes. But right here, the first time through, property name is equal to shoes. I better do this. We come in here, products object, give me the first property name, it sets it equal to a string. So for square bracket notation, it doesn't matter if you give it a string that you typed in yourself, or if you give it a variable that has a string as its value. It grabs the string and uses the string to figure out what's going on. These two are identical. Those are doing the exact same thing the first time through the for loop. Second time through the for loop, this gets changed to shirt, and so now this is looking for a property shirt, and this is looking for shoes still. Well, that's a problem. That's why variable names and not hard coding them can help you, because you don't know what those property names are.
From there, how would you get into the properties of the object inside that object? So like, how would you get into
Green. How would you get green?
Oh,
yeah, like how would you get into
so
object properties?
when I call productsobj.shoes, put it out here, what does it give me back? An object. How do I access properties on an object? Dot notation or bracket notation. So I could do dot color. Or I could do square bracket color. And just keep walking down. Do the same thing with any of the other variables. You're getting an object. You can do anything that you can do with an object. Dot notation or square bracket notation. So I could put the equal on the right to change the value. Or I could put the equal on the left to get the value. Whatever I normally would.
Can you do the same thing on that second to bottom line where you have products all that right there? Can you go right there?
Absolutely. Yep, now I'm getting the color of the shoes and then the color of the shirt.
Do both of those.
Once each time through the loop.
So if you wanted to loop through the properties inside of the property, you have to create a for loop, right?
If I wanted to loop through the properties inside of the properties, I would create another for loop. And then I would start questioning if this was a good pattern, if there's a better way to store my data. Whenever you have a nested loop, I start questioning. Sure, if I know that's what it's called. But I'm assuming I'm doing this because I don't know what all the property names are called, and I want to loop through them. Okay. So that's objects versus arrays and looping through objects and arrays in a very fast review nutshell. If you want to practice this, take something in the real world, something that you know, a hobby, things that you own multiples of, if you have collections of anything, people that you know, model them, make objects that represent them. Practice this. Build the data, build the data, build the data, build the data. Okay. Last thing I want to show on this is using objects to count things. I consider this a little bit of an intermediate technique, but we teach you guys, or at least if Brett didn't cover it, I'm glad I'm covering it now. Understanding that with objects, you can track two things, a key and a value, really easy. Can make it really easy when you end up in a situation where you don't want to track things by number, but by a string. Reasons that you might want to do this. You have a giant thing of data. You are YouTube. And you know you are given a list of 30 videos. And you need to go through and count That's a bad example. I'll use my normal one. So we're registering for a cover band convention. Okay? No, let's do bowling names. You're registering for a huge, like, worldwide bowling tournament. Okay? Everybody knows when you bowl, you can't use your real name. It's just awkward. You've got to make up a bowling name, right? Night Shadow, Rolling Thunder, Mr. McGee, right? The bearded one, something. As an interest of curiosity, your bosses, to try to promote things marketing, asked you to go through and count and find the most popular bowling names that are repeated over and over again. So you need to store two pieces of information: a bowling name and how often it was used. If you do that in an array, that gets messy, because you've got an index with an object with a bowling name with a count. If you do that with an object, var bowling names is an object, and I've got Rolling Thunder, shows up 99 times. Power Down Under shows up 90 times. Something obscene shows up 50 times. I need to track exactly two pieces of information by recognizing, hey, my key can not only describe the data, it could just straight up be the data. I get one piece of information, two pieces of information. Perfectly easy to track, and the code is a lot simpler. Okay. Normally, when I do this one as a review session, I try to have you guys do it to help learn it. But we only have 15 minutes, so we don't have time for that. So I'm going to walk you through this and then share the code so that you can hopefully, I really hope, if you're struggling with objects and arrays and things, this is like one of them that you go back and try to redo yourself. You'll have the code, go try to redo it yourself and understand what's going on each line. So this is counting cover bands. We're given a small sample of how bands register for our cover band competition. They give us a name, an email, and the artist they want to cover. We need to count how many times each artist was asked to be covered. Well, we don't want to have to make a database with every artist ever, so we're just going to let them manually put them in. So we have Queen, we have Led Zeppelin, we have David Bowie, we got one for Britney Spears, and a bunch more David Bowies. It ends up looking something like this if you use an object to count.
So the properties have to be in the same order each time?
On an object?
Yeah.
No. Because we only access them by property name, so it doesn't care what order it's on there. Order has nothing to do with objects. So this is what our end result should look like. Counts is going to be an object with David Bowie 5 times, Led Zeppelin 3 times, Queen 2 times, and Britney Spears 1 time. Okay. Does this look familiar? This is the array I just showed you. This is my code running live in the browser. What this allows me to do is put some breakpoints in here so that we can see exactly what the browser is doing every step of the way. I refresh. I'm going to call count cover bands. Step inside. We set up counts. It's an object. It's empty. Cover bands is an array of 11. This is the data we were looking at. So we're going to go over the cover bands with the for loop. In general, whenever I do a for loop, I try to pull the information I want to use out onto a variable, very first thing. It makes it very clear what I care about, and it makes it so that I have to do index I as little as possible. Which, trust me, you will change your logic and your index I's and other things, and this will save you some headache. Just good pattern to have. So, bands, right there. Index 0. Artist is queen. Bands, index 0, artist is queen. So we pulled queen out here onto a variable name. Then I use square bracket notation. Does counts have a property called queen? Here's counts. Do we have any properties? So do we have a property called queen? No. So my if statement fails, and I come into the else. And I say counts dot queen, or square bracket queen, artist name, is equal to 1. Now look at counts now. Now I have queen with a value of 1. Repeat this. I is now 1. Artist name is now Led Zeppelin. Does counts have an artist named Led Zeppelin? No. If statement fails, and we add Led Zeppelin. We're very heavily using square bracket notation when dealing with this object. This is real. I've solved code very similar to this, using this exact pattern. I wanted to use an object to count things because I only had 2 properties. What I wanted to count by was how often this string showed up. It's going to happen more than you think. So I add Led Zeppelin to counts, and now counts has queen and Led Zeppelin as properties. I is now 2. Artist is now David Bowie, so we add David Bowie. Our I is now 3. Artist is queen. So now we have something different because our if statement, does counts have queen? Yes. So we go inside and simply say counts, whatever you have for the value at queen, or 1, plus plus. So now queen is 2. And we can repeat that for every artist in here. Yeah. How many of you want me to go over what I just did with this debugger? Okay. Let's start from scratch on the debugger. You're on a web page. Any web page. Someone give me a random but professionally appropriate web page. Huh? Google.com. Great. I right-click inspect, Command-Option-I, Control-Shift-J, depending on Mac or Windows. And I get the terminal. Hopefully you've used this to look through elements and CSS, and use the side to look through the CSS and things. Hopefully you've clicked on console to look for errors. Hopefully you're familiar with at least those 2 tabs. I simply used another tab called sources, source codes, source files. I can come in here, coming straight from google.com, here is their index.js file. You want to know all the JavaScript Google is starting with on their page? Here you go. Hey, neat. I found a new button. So this made them print it out a little prettier. There was a little like curly braces thing down on the bottom that I clicked. It's gone now. Refresh. There it is. It's ugly. Oh, it remembered that I wanted it pretty. There you go. There's the JavaScript for Google. You can look at the JavaScript for any page that you can run in the browser. So they're loading their styles in. Yep. Okay. So that doesn't help us. We want to debug our code. Right-click, inspect, click on our sources, and sure enough, over here I had my index.html and my code.js. So right here in the browser, I have index, and then I have code.js. I click on my files. They're open. They are read-only. I can't go mess with them here. But then I can click on the numbers on the left anywhere I want. And when I do that, what I'm telling Chrome, I'm a developer, I know what I'm doing. Listen to me. First instruction I want you to follow is whenever the JavaScript engine comes to this line of code, freeze. Stop all things. Do not pass go. Do not go to the next line of code. Don't even run this code. Tell me at the start before this thing happens.
So it freezes out. So everything before line 60 is frozen, and after 73.
So right now, it froze first on 73. Why? Because I haven't invoked 59, so 60 never got hit yet. Why do you not like me? Oh, duh. So this is the first breakpoint that it hit. The first point in the code that I told it to break execution, stop running, and let me look at what's going on. I have bands. I can hover over things. I can look at them. I can drill in. What's at index 6 of bands? It's Joey wanting to cover Britney Spears. Here's Johnny Depp wanting to cover David Bowie. So on and so forth. I can look through all the data that I want. And with these buttons here, I can drive. Instead of telling JavaScript, hey, keep going, you say, you follow the steps in the order I tell you. So you have 4 basic commands. The blue arrow, resume script execution. Off of the name, what do you think that does? It just unphrases. It says, hey, I saw what I wanted to see. You keep doing your thing. Right? If this breakpoint's not here, push that button, it never hits another breakpoint. If I wanted to know only the times that it came in this if statement, I can say go. It ran through all that code. Yes, that fast. Computers are amazingly fast. And now if I look at counts, it already added all the basic people. It did our first 3 loops until this if statement was true, which is the only way I got to line 64. Line 64 doesn't run unless this if statement's true. So I got in here. Yes, counts has an artist called Queen. So I stop right there. That's the first command you can give it. Keep going until you get to another breakpoint. If it never gets one, it never freezes. If it gets to one, it freezes again. This can be great, because I'd be like, okay, when's the next time I come in the if statement? And when's the next time I come in the if statement? And when's the next time? Oh, wait. Is there any other time that I go into the else statement? Nope, not at that point. Never got hit, so that line of code never got run again. The second command you can do to drive is step over function call. Basically what that means is don't don't go in any functions. Invoke them and come right back. So if I click this, I'm not going to go to line 60 inside the function. I'm going to go to line 74 because it's the next one that doesn't mean going inside a function. Step over the function. Don't go inside it. Oh, I had this breakpoint here. That took precedence. So I'd have to get rid of that. Restart, try this again. Step over. I go to 74 and not inside the function. Down arrow. Step into function call. Do I want to know what count cover bands is doing? Yeah. So I click that, and now I go inside the function. And now I can use this one to go, well, go to the next line in this function. And I'm slowly walking through the code. Pro tip, you can't break this. You can't break code driving. You can't break the debugger. If you're like, oh, I feel weird, I'm not sure what I'm doing, who the heck cares? Go do it. Go watch what happens as you push the button and all the buttons and figure this out. The last one, step out of function. I looked in here, oh, I see the problem. I found my bug. I get what's going on. I'm done looking inside this function. I want out. It just skips anything else inside of there and goes to what would be the next line after the function we were inside. That's the debugger in a nutshell. You can get it at watches. Looks like I have some from last time. I step in. I have a watch on I, a watch on artist name, a watch on counts. Add a watch, just hit this plus, type in something. Cover bands index 3. It's an object. That one's never going to change. Cover bands index I, undefined. As I step through this, my values are going to change here on the side to reflect what's going on live in the code. This can be a neat tool to track changes to something over time. There's more with the call stack. You can start looking at things dealing with scope. You have your list of your breakpoints. I don't want to overwhelm you. Simply learning to drive and hover and looking at things can take you very far. I'm going to say this last thing since you wanted me to dive into this with the debugger. I would have a really hard time hiring anyone, junior or whatever, that was completely incompetent with a debugger. They call them computer scientists. We'd like to call ourselves engineers in computer science. That denotes a certain level of problem solving through fact and information and understanding, through logical processes. The debugger is the first tool to adequately understanding how JavaScript is really working underneath. The debugger separates a throw it at the wall and refresh the page and hope it sticks programmer from a logical problem solver who wants to not guess, but see what's really going on, stop and think and say, hey, if A, B, oh, now I see where the disconnect is. True story. Company brought in some of our recent grads, wanted to hire them. Heard the story from the grads and then later from the company. Did a short, very short interview. Took them in a room, put them in front of a computer, showed them JavaScript code on a page, said, this is broken, and walked out. They were recording, well, they didn't walk out, but they went quiet and they just started watching. What would you do in that situation? What goes through your head? They want me to fix it, right? Crap, I've got to fix this. The reality is they picked some really obscure, super hard to find bugs that took them weeks. And they weren't looking for someone who could solve their week's problem in an hour or a half hour. All they wanted to see is what methodology did the potential hire use to try to start getting clues and information to solve things. The grads who went in there and they just kind of stared at the screen and then refreshed and then clicked around and then went straight to the code and started looking at the code didn't get good marks. They did not impress the employer. The grads who instantly went in there, console, there's no red errors. Okay. Let me find an element. Let me look for a click event on that element. Let me dig around in the debugger to try to get clues. They got very good marks because it sent the message, hey, I know how to dig around and find clues to try to figure things out myself. I'm not going to get stuck on every little problem. I might get stuck on big problems and need your help. But I'll try to figure things out myself, and I'm comfortable enough looking for facts that I can do that. I can't overstress how important learning the debugger is. On top of job prospects, on top of turning employers off, I literally, firmly, deeply believe that knowing the debugger really well makes you a better programmer. Because it means you can think exactly like the computer thinks, because you've watched it over and over and over and over again. Okay, hopefully my little like soapbox motivation pep talk worked, and you're all going to come back from lunch and hit the debugger for a little bit. If, huh?
The project today is working the debugger.
Is it?